This is a quick screencast about the relationship between latitude and your altitude of Polaris. I'm using the astronomy program, and you can see I'm looking towards the north. My location right there, you can see, is 0 degrees, which is the equator, and Polaris would be at the horizon. I'm going to change it to 1 degree north, and look what happens. Polaris pops up over the horizon. So I'll go back to 0, and watch it's going to go. It's at the horizon right now. So, Polaris on the horizon, the altitude would be 0 degrees off the horizon, therefore I'd be 0 degrees latitude. 1 degree. Now it's 1 degree off of the horizon, therefore I must be at 1 degree north latitude. Check it out. I'm going to go to 10 now. If I measured this angle from the observer to the horizon to Polaris, it would be 10 degrees off of the horizon, which happens to be equal to my latitude. 20 degrees, it's going to pop up. See it? Now if I measured the angle from the horizon to Polaris, it would be, how many degrees? Very good, it would be 20. So now if I do this, if I change this to 30, it's going to, there it is, and you can see that Polaris is 30 degrees off of the horizon, which happens to be also my latitude. I could play this game all the way till, let's say, 40, and you can see it's getting higher and higher. I'd have to lift my head up higher and higher in order to see Polaris. So that you know that your altitude of Polaris will give you your latitude, and if you know your latitude, well, then you could determine the altitude of Polaris. So it kind of works in both directions there. Go to 50 degrees, you can see here, it's at 50. It's 50 degrees off of the horizon if I measured that angle. And now if I go to 60, what's going to happen? Well, I have to move my observer a little bit. Now if I measure the angle off of the horizon and see that Polaris is 60 degrees off of the horizon, which would give me my latitude, there is 70 degrees. Let's check that out. So see, I'd be 70 degrees off of the horizon, which gives me my latitude. 80 degrees. Well, I would look here and I would see, okay, Polaris would be 80 degrees. And finally, the maximum, 90 degrees. There's the horizon. I would have to look where to see Polaris? Directly overhead, or at the zenith, is where I would look to find Polaris, because my latitude is 90 degrees, and it would be directly overhead. So that's the maximum altitude that Polaris can have, would be 90 degrees. Which brings us to this question. The diagram below shows an observer on Earth viewing the star Polaris. What is the observer's latitude? You can try and figure that one out for yourself, and when you see me tomorrow, you can tell me what letter the correct answer would be. And if you get it right, it might sound like that you're telling me yes in Spanish. Muy bien. And the last thing I'm going to talk about, and don't cry, you'll hear my voice soon enough, is if you look at this page, page 3 in the Earth Science Reference Table, you could find various cities. So now think about what we said earlier, or actually I think what I said earlier. Your altitude of Polaris will give you a latitude, but also your latitude can give you the altitude of Polaris. So for example, look at Slide Mountain, and if you remember from previous fun sheets, Slide Mountain is at a pretty nice latitude of 42 degrees north. That's its latitude. Therefore, how high in the sky would Slide Mountain be? If I looked at Polaris, obviously at night, and obviously I'd have to be looking to the north part of the sky, but if I measured that angle from the horizon to Polaris, what would be its measurement? Think it, think it, think it, think it. And if you thought 42 degrees off of the horizon, you are correct. So obviously any of these cities on this wonderful map of this great state in the greatest country in the world, you should be able to tell us what the altitude of Polaris would be. That is it. Like I said, promised a pretty quick screencast, which is very difficult for me to keep things brief. So enjoy your day.